Hey everybody, let's do this problem again, except this time we're going to do a slightly different method. In previous videos we've looked at method of joints. In this video we're going to look at the method of sections. And the difference is depending upon what we're looking for. If I want to know all of the forces and all of the members, then method of joints is just as easy as method of sections. But maybe I don't need to know all of them. Maybe I just need to know some of them. So for example, in this particular system, maybe I just want to know the forces from D to F, E to F, or E to G, right? And in that scenario, what I do is I'm just going to section this thing off. And so what we do is we mathematically make a cut, all right? And so I'm going to make a cut through there. And then I'm going to look at the forces acting on, and I can pick left or right side. I'm going to choose the left side, but I can look at the forces acting on the left or the right side of this system. And so this is going to look something like this. When I do this, there's going to be, there's this point right here, E, and then I've got this, right? So here's D, here's A. There's still a zero force member from C to E, so I don't need to worry about that. And then I'm going to have these guys cut in through here. All right, and so I probably should have done those in blue, but let's just put the arrow tips in blue. All right, so what have I got here? I've got a 900-pound force here. And then I've got 400-pound force there. All right, and I have TDF, TEF, and TEG. All right, so there are my forces. Right, there are my forces. And let's get some angles in here. This is theta, but this is alpha. And from previous videos, same thing here. Tangent of alpha is 2/3, and the tangent of theta is 1/3. All right, so I've cut this section. Right, I've sliced it up right through there, and I've cut a section. Now your cuts have to be like basically up and down. You can't come through and around, and you don't want to do that. First off, you can't do that, but you don't want to. So you make your cuts nice and clean. All right. So continuing on with this, then some of the forces in the x, some of the forces in the y. So we'll do the sum of the forces in the x, and that's basically on this whole section, right? So I'm taking this section of the truss, and I'm looking at the whole section. So I've got, well, the 900 and the 400 are both up and down, so we forget that. So I'm going to have TEG, that's purely x, right? So that's easy. TEF, then cosine of alpha, that's in the x direction, plus TDF, cosine of theta, and that's all equal to 0. So I have 3 unknowns in there. I don't know any of those at this point. Right, so 3 unknowns. I'm going to need 3 equations. Sum of the forces in the y. I've got 900 up, 400 down. I've got TDF, sine theta, and I've got TEG, sine alpha. Of course, TEG does not have a y component, so that's all equal to 0. That's 2 equations. I need a third equation, and it's going to be the sum of the moments. So where do we want to sum the moments? Well, there's a couple of good spots, and there's some that are not as good. But I'm going to choose the sum of the moments about A. Okay, and the reason I do that is TDF and TEG, the line of action of those 2 forces goes right through A. I can eliminate them from my system of equations, or excuse me, from this equation. So I have the sum of the moments about A. 900 pounds is right there at A. 400 pounds is not. 400 pounds is going through D. which is a distance of 6 feet. The line of action is a distance of 6 feet. Okay, so that's going to be 400 pounds times 6 feet. And then, right, that's the perpendicular distance, and that's going to be clockwise, so that's negative. And then TEG, no moment. TDF, no moment. Then TEF. So TEF, there's a component in this direction with the line of action. That component goes through A. So I only want the component in the upward direction. So that's going to be TEF sine of alpha. And that's acting here at this point, so that's also times 6 feet. And that's going to be positive because it's trying to lift it up. It's a tension, right? I could be wrong on the direction, but that's the way I've drawn it. So it's going to be counterclockwise, so that's positive, and that's all equal to 0. And so there's only one unknown there, and that's TEF. So I can solve this one for TEF and then put it back into this equation, and then I have two equations and two unknowns, because notice TEF is not in the y equation. So I have a system of two equations and two unknowns which we can solve. I won't do that, but that's a solvable equation or system of equations. All right, and that's how the method of sections works. Kind of slick, right? That seemed to have gone a lot better than the method of joints, which took 3 videos. But I'm only finding a portion of what's going on. I didn't find anything about what's going on over here or what's going on over here. So is it a better method? It's a different method. They both have their ups and their downs. I usually try to go with method of sections if I can. But if I can't, then I have to go to method of joints. Or you might be specified which set do you want to use. Do you want to do method of sections or method of joints? Doesn't matter what you want. You might have to use one or the other. All right. Okay, if you have any questions on the method of sections in this truss, please leave them in the comments below. Thank you.